Okay, so this is video 4 of the series on the lectures on logic gates. So I hope you have been following the series so far. If you have not, don't start this video until you have watched the first 3 videos, okay? All right, so far I've been talking about logic gates and logic states, high, low, 1, 0. I have not really given you much context as to how these are being used, right? And so that's what I'm going to address in this video, the context, like what for, why are you learning this for? Definitely not to impress your girlfriend because girls don't like these things. Sorry, that sounded very gender biased. My bad, I take it back. But yeah, so I think it'll help you understand better if you get some context to this. Okay, so this is a situation, this is in your textbook, work example 11.2. So the situation is, this is the story. To attract customers during off-peak hours, an eatery, you can read it yourself. So basically, I've got 2 decisions to make, right? I need to consider the day of the week, and I need to consider the time. So let's say day of the week, let's represent it by D, time by T. So if it's Friday to Sunday, let's give it a low input. Now, how it's going to decide is low is another part of the story. I don't know what sort of circuit has occurred here. I don't know, but I'm assuming that it's going to be able to give me a low if it knows that it's a Friday to Sunday. Probably has some counting circuit, therefore gives you a calendar kind of arrangement. But I don't know, I don't care. So right now, all I know is that if it's a Friday to Sunday, it's going to give me a low. If it's a Monday to Thursday, it's going to give me a high. Okay, so same thing for time. I don't care. I don't know and I don't care. This should apply to a lot of you. I'm going to use it on you now. I don't know and I don't care how I get this 0 and 1. All I know is that there's this situation, 2 to 4:30. Let's give that a high. Any other times, I'm going to give it a low. So the story is, it will only give me a service charge if if sorry, it's only gonna stop the service charge if it's from Monday to Thursday and is 2 to 4:30. Okay, so it might be a bit fuzzy now. So to help you understand the situation, we are going to draw a truth table. Same thing, this input D, input T, these two, you don't have to think. Remember the pattern, 0011, 0101, write it down. So now it will only remove the service charge. It will only remove the service charge. No service charge if it is only Monday to Thursday and between this time. So both needs to be 1 in order to have no service charge. In order to have no service charge. Any other days, any other times, there will be service charge. You got to pay, son. All right. So this is the truth table. And those of you who have followed the video lesson, you'll recognize that this truth table is the truth table of a NAND gate, not AND. Yeah? So very simple. To help us make the decision, it's going to help us by deciding when it's going to start service charge, when it's not going to start service charge. Okay, so probably the waiter can just, based on this circuit, be able to tell maybe this fella is a green light, red light, I don't know. There are many different ways to tell me when it's a 0 or 1. And based on the color, based on the output, the waiter will know whether to charge the customer service charge or not. Okay, so this is the work example, and this is the review question on page 281. So I'm going to help you do the first one. Okay, well, this is the Boolean expression. Since I'm here, I'm going to help you do it. So I've got the output X, I've got the output X, I've got 2 inputs. Yeah, this seems to be the output truth table for a NOR gate. Okay, you can go and check it up. You can go fact check me if I'm wrong. So a NOR gate is A or B, not that. Okay, so this should be the answer for this, right? Go and fact check me, tell me if I'm wrong on this. Now, but this is what I want to go through with you, the whole situation and the context thing, right? So I'm going to do the first one. I'm going to do the first one, and then you will do the second one yourself. All right. So situation one, car park entry barrier should rise if there's a car waiting to exit and the correct parking fee has been paid. So the first one, if there is a car, so I'm going to say car. All right. Okay, so if there is a car, if there's a car, I'm going to have a 1. So there is a car, and a 0 means there is no car. Okay, so this is the car. Now next, has the fella paid the parking fee? So let's put it as a parking fee, F for fee. All right, so 1, he has paid. 0, he has not paid. Okay, and the barrier, so the barrier, the exit barrier, let's put it at barrier. So barrier, if it's a 1, it means that it is okay. So let's raise the barrier. If it's a low, means do not raise the barrier. The fella ain't paid yet, son. Okay, so these are my situation. I'm going to draw the truth table. So there is two inputs. Oh, I'm going to have the truth table. The first input is C, the second input is F, and the output is B, right? The barrier. So same thing, remember the pattern. 0, 0, 1, 1. Okay. And the next is 0, 1, 0, 1. Now, the barrier will only rise if both car and fee have been paid. So it will only rise if both car and fee has been paid. So only if both are high. So it will only rise if both car is there and the fee has been paid. If the car is there but he hasn't paid, don't raise the barrier. Son ain't paid. Or if there's no car but mysteriously the fee has been paid, you win lah, but still don't raise the barrier. And if there's no car, there's no fee, for goodness sakes, please don't raise the barrier. Okay, so this corresponds to a AND gate. So this is a AND gate. And I want to write the Boolean expression. So the Boolean expression is, for an AND gate, output is B, C, and F. So this is my Boolean expression. Okay, so this is how I navigate the situation. I have to first come up with um, the unknowns and what 1 represents, what 0 represents, and then the output, what 1 represents, what 0 represents, and then from the situation, the story that has been told me, I write down which output is a 1 and which outputs are zeros, and then from there I need to be able to recognize, hey, this reminds me of an AND truth table, or this reminds me of OR truth table, so on and so forth. And from there, coming out with your Boolean expression should be simple. Okay, so again, go try. I want you to try the second scenario. I want you to try the second scenario, and once you've done, bring it to school, show it to me so that I can give you some feedback. All right, and with that, I will stop this video now, and then I'll go on to the last part in the next video, talking about IC chips. Okay, so remember, your homework after this video is to try out the second scenario and let me see it in school. Okay, so with that, see you.